Let's look at simplifying radical expressions. Three basic principles involved here. That's the radical sign. The number under the radical is a radicand. A stands for any number here. Now this is the square root of a. In that case, the index is 2. But we don't generally write the 2 for square roots. It's understood to be 2. For any other index, we have to write it. So here the index is n. So this is the nth root of a. If n was 3, this would be the cubed root of a. Suppose we are raising a to the nth power. That is, we're raising a to the same power as the index. Then that equals a. That's principle number 1. Now there are some special cases when n is even and a is negative. We'll worry about that later. Second principle. The nth root of a times b is equal to the nth root of a times the nth root of b. That is, the nth root of the product of two numbers is the product of the nth root of each number. Third principle. The nth root of the quotient of two numbers is equal to the quotient of the nth root of each number. Now, let's look at a couple examples from this. The square root of 4 times 3 can be written as the square root of 4 times the square root of 3. So the square root of the product is the product of the square roots. Example here, let's look at the cubed root of 6 over 8. We could write that as the cubed root of 6 over the cubed root of 8. Now, neither of these radical expressions is simplified. They're just rewritten. But notice that the square root of 4 is 2. That is, the square root of 2 squared is 2 from this principle. So we could rewrite this as 2 square roots of 3. Now this radical expression has been simplified. The radical expression is simplified when this radicand is the smallest possible number. Now, the cubed root of 8 is equal to the cubed root of 2 cubed, right? 2 times 2 times 2 is 8. So this is equal to 2. Now, this radical expression has been simplified. So we need to get familiar with some perfect square roots and some perfect cubed roots. The square root of 4 is 2, as we said, because 2 squared equals 4. And the square root of 9 is 3, because 3 squared is 9. And the square root of 16 is 4, because 4 squared is 16. And the square root of, well, what? The square root of something is 5. What is that? Well, 5 squared is 25. So it must be the square root of 25 that is 5. Let's look at some cubed roots. The cubed root of 8 we said was 2. Why? Because 2 cubed is 8. So what is it? The cubed root of what gives us 3? Well, 3 cubed, which is 3 squared times 3, which is 9 times 3, and 27. So it must be 27. One more. The cubed root of what is 4? Well, 4 cubed is 16 times 4, which is 64. So I've written them in order. 2, 3, 4, 5. 2, 3, 4. Now let's use some of this to simplify some radical expressions. Here's what we have to work with and our 3 basic principles. So let's look at, let's say the square root of 48. I'm going to look for the largest number that divides evenly into this. 16 goes into 48 3 times. This is the square root of 16 times 3, which is the square root of 16 times the square root of 3, which is 4 square roots of 3. Now, you may be asking, what about 4? I noticed that 4 goes into 48 also. Yeah, we could write that as 4 times 12. But I also notice that 4 goes into 12. So we could rewrite this as 4 times 4 times 3. 12 is 4 times 3. Now let's write this as the square root of 4 times 4 times the square root of 3, which is 4 square roots of 3. Same answer. Let's look at one more. How about the cubed root of 54? Now we're looking at cubed roots. Whoops. Any of these numbers go into 54 evenly. Looks like 27. So this is the cubed root of 27 times 2, because 2 times 27 is 54. That's a times. Which is the cubed root of 27 times the cubed root of 2. And that cubed root of 27 we said was 3. So this would be 3 cubed roots of 2. This expression is fully simplified. This is the smallest possible number that we could have under the radicand, or under the radical sign. Sorry. The radicand is the number under the radical sign. Now we'll talk about simplifying radical expressions that contain variables in the next video.